Today's lesson is section 6.4. We'll be doing A and B in this video. It'll be over inverse trigonometric functions and right triangles. So here, first example, we want to find all angles theta between 0 degrees and 180 degrees satisfying the following equations. So letter A wants you to find the sine of theta equals 0.6. So what angle for sine gives you a ratio of 0.6? So we would do just like we did the other day with our calculator. So you would want to take the inverse sine of both sides, okay, so then those cross each other out, you're left with theta. So inverse sine of 0.6, if you plugged it into your calculator, and we're talking about degrees, so make sure your calculator is in degrees. So second sine button gives you the inverse sine, 0.6, parentheses, gives you 36.87. Okay? Now here it says it wants all the angles in between 0 and 180 degrees that satisfy this equation. So this first one would be in that interval that we talked about the other day, where sine must be in between negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. But here, since they're changing the area, or the area of possible solutions, sine is also can be 0.6 in the second quadrant, where 90 to 180 degrees is. So I would need to actually find the other one. So to find the other one, I would take 180 minus the one I just found. Okay, so then that gives me 143.13 degrees. Okay, so I have two answers for this one. Okay, now let's look at cosine. So cosine theta equals negative 0.6. So I want to find where the inverse of cosine gives me this angle, or this ratio. So those go away. Theta equals cosine inverse of negative 0.6. Okay, so then we'll plug that into our calculator as well. Okay, so I get 126 degrees. 0.87 as well. Okay, now here, cosine is only negative, like that's our usual area between 0 and 180 for cosine. So there's not another angle in between that. The other angle would be in the third quadrant, because that's where, or that is the other place that cosine is negative. So this one only has one answer for letter B. Okay. Okay. The next part, we'll talk about composition of trigonometric functions. So here I want to be able to find the following. So cosine of sine inverse of 4/5. So now this one, it might be helpful to construct a triangle to help you describe what's going on. So if you have a triangle, you have your angle, okay? You don't know your angle. They don't give you anything about like what that angle would be. It says 4/5, okay? So here you're not really concerned about the angle at all, okay? Because you're doing a trig ratio of another trig ratio, and so like the inverse of it. So it's like thinking that something's, so if you're talking about sine, remember that it's the, for your ratio, it's the opposite over the hypotenuse. So for this angle, 4 would be your opposite side, hypotenuse would be 5, So then now, maybe knowing the rest of the triangle, because you're going to be asking cosine, so you need to know what the adjacent side is. So do your quick Pythagorean theorem here. And then subtract that over. Now, usually I'd say plus or minus for the square root because you put it in, but we're talking about a triangle, so it has, unless we're in a negative area, our ratio is 4/5, so it's going to be positive as of right now, so it would be a positive 3. Okay, so now, it's almost like saying cosine is like your angle, theta, is of this triangle, okay? So this is that, basically. And you found your angle. You don't really know what your angle is. You could probably find it, but you don't need to find it, because now I want to be able to find cosine of theta. So now cosine of theta is just a ratio that's from your triangle. So it's adjacent over hypotenuse. So that gives you 3/5. So for these ones, you're going to be given a ratio, and you're going to spit out a ratio, okay? So you shouldn't have to really write down what angles are what. So you won't really need the inverse trig function on your calculator for this one. Letter B, it says cosine of inverse tangent of 3/4. Same thing, let's make a triangle. So remember, that's the opposite over the adjacent. So 3, 4. Okay, now we just did that triangle. 3 squared plus 4 squared is 25. Square root is 5, right? Okay, so we already know this triangle's values. So then if I'm doing the inverse of tangent of 3/4, then remember that's just cosine of theta, which is that triangle. You found the angle by writing the triangle. Now you want to find cosine of that angle, which is the ratio. So then adjacent over hypotenuse gives you 4/5. Okay? So that would be your answer there. So the triangles help you very much so to give you a visual of what you're doing. Okay? So remember, you're given a ratio, you get a ratio. Now this one's a little different. Okay? So here it says sine of cosine or inverse cosine of x. Okay? Still draw your triangle. You have an angle. Okay? Now cosine is the adjacent over hypotenuse, right? Okay. So adjacent, in this case, your ratio, now it's kind of deceiving, but it says x, but think of a ratio as a fraction, so x over 1 is your ratio, so adjacent would be x, hypotenuse would be 1. Okay? So now the trick is to find what your opposite side is, because you need it for a sine. So you have x squared plus whatever squared, a squared, equals 1 squared. Okay? Now here you'll want to move your x squared over. 1 squared is 1, so I can just write that. And then from there, I need to take the square root. Okay, so the opposite side is the square root of 1 minus x squared. Now remember, I can't reduce that because it's a binomial. I need to have 1 minus x squareds to be able to cancel that out. The minus makes it so you can't multiply or pull them out of the radical. So then now, just like we did before, this is equal to sine of theta. Okay? Your triangle gives you your theta, And now I want to know what the ratio of sine is, so it's the opposite over the hypotenuse. So in this case, which I would always want you to reduce down to 1, or get rid of the 1 on the bottom. So just square root of 1 minus x squared in this. Okay? Now that one's a tricky one, but make sure you remember, the key is to remember that that's a ratio, not just a variable. Okay? So, okay, have fun.